Okay, welcome to YouTube online homeschool. Today we'll be talking on volume of earthworks on road project. We are going to solve an exercise. Okay, on this exercise, we have been given under the formation width of the road, which is under 12 meter. We have been given the gradient of the road, which is under 1 to 60 meter, and we have been told the gradient of the road is a falling gradient, that is a minus gradient. And we have been given the formation level at the starting point. It can be a change 0. We have been given the formation level to be 470 meter. Then we have been given the ratio of the side slope 1:2. For the side slope, we have been given two ratio. We have been given the ratio for embankment and we have been given the ratio for cutting. For the ratio of embankment, we have under 1:2. For the ratio of cutting, we have 1:1.5. Then I want us to calculate the quantity of earthwork for the road using the mid-sectional method. Then if we look below, we are going to see a table, and on that table we have the change point of the road, and we have the reduced level of the ground level. So we have from the change point, we have a change point from 0 to 150. So actually, it's a road of one. The length of the road is 150 meter. The width of the road, the formation width of the road is 12 meter. Then the side slope of the road for embankment is 1:2, and for cutting is 1:1.5. And the different height of natural ground, which is the GL ground level, has been given in the different on a different change point. Now, this is just a planimetric view of the corridor that was allocated. We have the change point along the center axis of the corridor. We have this on the change point PK0, we have PK plus 30, we have PK plus 60, we have PK plus 90, we have PK plus 120. And I want us to calculate the volume of earthwork at each section, that is from PK to PK from PK0 to PK plus 30. We have to calculate the volume of earthwork that will be needed. Either we are bringing in earth into the site, or we are taking out earth from the site. Then from PK0 plus 30 to PK0 plus 60, we also have to calculate. So at each section, we have to calculate the volume of earthwork that will be involved. Then now, this is just a cross-sectional representation of this corridor. We have the ground level GL, we have the natural ground level. So height of point have been taken on natural ground level, yes. And we have been given the formation level of the FL, the formation level of the first point. Then we know that this D is the distance to cut from the natural ground to the formation level. Okay. Then we have been given the side slope. So here we are seeing that on this first section, we are seeing that we have to cut. There will be a cutting to arrive at the formation level of the road, and here there will be filling to arrive at the formation level of the road. But how much groundwork or how much cubic meter of groundwork will be needed at each section? We have to do it. We have to calculate it right now from the data that has been allocated to us. And given the reduced level of the GL, change of the first point, which is 470 meter, 4,700 meter, and the falling gradient, which is 1:60, the formation with B, which is 12 meter, So this by definition is and the slope in banking is filling. The slope in banking is the horizontal distance moves to the vertical, which is 2/1. Same thing, the slope in cutting, which is the horizontal distance moves to the vertical, which is 1.5 all over 1.5 over 1. If we look here, this is the slope either in banking or in filling, which is S is to 1. And from here, we say the slope is defined by the horizontal distance moved to the vertical distance. Then now we have to calculate, generally, to calculate the volume, we must know the surface area of the side slope, and we have to know this on the surface area of the central portion. Now, knowing if this was pk0, if this was pk0, if we are to know the distance from pk0 to pk30, which is 30 meter, of course, we can now calculate the volume of earthwork that will be required here. Now, the first thing is we have to calculate the formation level at each point of the road. You understand? Because the formation level is actually the project level. So, because if we do not calculate the formation level, we are not going to know the depth of cutting or the depth of filling, and it's with that depth of cutting and filling that we are going to use to calculate the volume. So, actually, the formation level is given by the formula formation level at the previous chainage plus or minus gradient multiplied by the chainage difference. Let's take for example, we already have the formation level of the first chainage, which has been given as 4,700 meter. Now, what is the formation level now at the next chainage? So the formation level at the next chainage, which will be chainage 30, will be formation level at point zero, which was 4,700. Sorry, it was 4,700, not 4,700. It was 4,070, not 4,700. So formation level at point zero, which is the previous chainage formation level of the previous point, minus the gradient. Remember, they told us that the gradient is a falling gradient, so the road we are declining rather. So minus the gradient multiplied by the chainage difference. The difference between chainage 0 and chainage 30, of course, is 30 meter. So the formation level at chainage 30 is going to give us 469.5 meter. If we follow the same procedure, the formula, we are going to calculate the formation level at chainage 60, 90, 120, and 150 meter. Now the depth of cutting or filling here will be formation level formation level minus ground level. That is FL minus GL, which is FL minus GL. We are going to obtain the depth of cutting. So we are going to see that at chainage and 0, we are going to do banking. Banking, that is filling. At chainage and 30, we are going to do banking. Chainage 60, we are going to do banking. Chainage 90, we are going to do banking. Then from chainage 120, we have a minus. That means we have to cut. At chainage 150, chainage 120, we have a minus. We're going to cut. Chainage 150, we have a minus 1.5. That means we are going to cut. Now, this is a representation of the longitudinal profile of GL and FL. Now, the one with blue is actually the GL, the profile. From chainage 0, we use the horizontal scale. We choose a horizontal scale to represent it. So our horizontal scale was on the our horizontal scale was on the 1:2,500, and our vertical scale is 1:200. So after representing the chainage point on the x-axis, which are the distance, we can now, and after representing the height of the height of the change point on the y-axis. So we, for example, on the change point of 30, this is the height, change point 0, first of all, change point 0, this is the height of change point 0, which was calculated. And the change 30, this is the height right up to change 150. From there now, we can link the point to obtain the longitudinal profile. Then the G, that is for the F, for the GL. Then the FL that was calculated, we did same procedure and we could link the point. Now you see that somewhere on our profile, there is, and before we go there, we are now seeing that from change 0 to change 30, we have VL, that is the volume of earthwork. How much volume of earthwork are we going to cut at this section? That is our calculation. And from change 30 to change 60, how much volume of earthwork are we going to cut from this section? Then change 60 to 90, how much volume of earthwork are we going to cut from this section? Then when we arrive, we are going towards change 120. We notice that there is an intersection between change 90 and change 120. That intersection is actually point of zero work. That means at this section of the road, there won't be any cutting or any filling. So we have to calculate the distance that we have to move to arrive at the point of zero work previously. Okay. So we are going to calculate the distance that we can move from point of from the change 90 to point of zero work. Now, calculation of on a point of zero work, at a point of the zero work, we are going to use under similarity of triangles. Remember, from our profile, we could see the change 90, and from change 90 where they intersect, change 90 intersect, and the GL from change 90 intersect the FL somewhere at this distance. We are going to call it X. Then now we have a distance from this and point of zero work to change 120. We are going to call it and 30 minus X, of course. Then now, what is the distance from year to year and what is the distance from year to year? We can calculate it using the formula of similarity of triangles. And if we use this formula, we are going by this solution x all over 0.3 is equals to 30 minus x all over 1.7. If we use this formula, we are going to come out with the distance from change 90 to the point of zero work. And the reverse, we can now calculate the distance from the point of zero work to change 120 meter. Good. And calculating the volume of earthwork is usually done using the table. It's used using table. This is by mid-sectional method. If you look here, we are going to see that we have on the table we have the change, we have the FL, we have the GL, we have the depth of cutting, then we have the GM. The GM actually is the mid, that is the midpoint, the mid height between the mid height of depth, yes, between between two change points. So we can calculate also the surface area of the central point which is B, the formation width of the road multiplied by D. If we want to go of course, if we want to, we have something like this. Do not forget, we have something like this. So this is actually the center. This is the B here. The B is the distance. The B is the distance from here, from this point to this point, which is our formation width of our road, and the depth. The depth here. This is the depth. This distance. So actually, we can calculate the area of this point, this portion, which is B times Z. Of course, it's a simple triangle, simple rectangle. Then now we can calculate the side slope. If you look here, we have calculated the formula of side slope has been given. We calculate the side slope of it between two sections. At the end of the day now, we need to calculate the total surface area, in each section. When we have calculated the total surface area in each section, and we have the length between the point, the length. If we look here, we are going to see have the length between the point. But if you look here, you're going to see that there's some points were 4.5 and 25.5. If you remember, those were the points between the change between the change zero. At the end of the day, since we have our surface area, we have our length, we have our total surface area between the change point and half our length, we can now, with this formula, quantity equals to area multiplied by the length, we can now calculate the volume of earthwork involved in each section of the road. So at the end of the day, we have calculated the volume of earthwork, banking and cutting. And the work shows that we are going to need under 2,524.1 meter cubic of earth for filling, and for cutting we are going to need under 9,708.91 meter cubic for cutting. So if we want to take a balance, and where you see that if we want to know how much ground we are going to bring into the site, that means we are going to take 2,524.1 meter cubic minus the 9,789.98, 978.98 meter cubic. So it is going to give us the volume of earthwork that will be required on the ground, required on the site for the roadwork. And this and the estimate are very important to estimate or to give the total cost of the project. Errors here can be very fatal because some roadwork, as we earlier explained, some roadworks can take close to 50, 60, 70% of the cost of the project, especially roadwork on the accidental side or mountainous side. So volume of earthworks on such area can take 60 to 70% of the project. Now that we have had our now that we have had our this thing, our volume of earthwork at the different section of the road using the mid-sectional method. Of course, we can still use another method to calculate we can use the trapezoidal method, we can use the area method to do the same calculation to calculate the volume of earthwork. Okay, thank you guys. So in our next class, we are going to talk on vertical curves. We are going to discuss and try to put some exercises. Okay, thank you and stay blessed. One don't return.